All right, thank you very much. So welcome to my Black Hat briefing, Controlling the Source, Abusing Source Code Management Systems. I'm Brett Hawkins. I'm with the Adversary Simulation Team at IBM X-Force Red. So an agenda for today, I'm going to go over an introduction just of kind of key motivators around this research. Then I'm going to get into a background on source code management systems, where I'll go into diving deep into attacking 3 popular source code management systems, including GitHub Enterprise, GitLab Enterprise, and Bitbucket. Then I'm going to go over a tool that I wrote called SCM Kit to help facilitate these attacks. I have 3 demos put together where you're going to see a software supply chain attack. You're also going to see lateral movement from source code management systems to other DevOps systems. And I'll wrap things up with the defensive considerations and a conclusion. So just a little bit about me. So I'm Brett. I'm on the Adversary Simulation Team at X-Force Red, where we do 2 to 3 month engagements, kind of going after an organization's crown jewels, testing their detection response capabilities. Prior to my time at X-Force Red, I wore a number of different hats, both on the offensive and defensive side, at Mandiant, JP Morgan Chase, and the J.M. Smucker Company. I've spoken at a number of conferences, including DerbyCon, Wild West Hackin' Fest, B-Sides, and Hackers Teaching Hackers. I'm also an open source tool author, so I'm the author of Sharp Persist, Invisibility Cloak, and now SCM Kit, and I was a contributor to the Due Diligence Project. So first off, how did this research come about? Firstly, just real-world experience attacking these systems. More and more our clients are asking us to go after these systems, just because of the role that they play. If you think about it, in today's world, software is running on everything. It's running on our cars, it's running on our traffic control systems, our medical devices, and much more. Okay? And that software running is source code. That source code is developed and maintained within these source code management systems, which makes them a very juicy target from an attacker perspective. And we're starting to see that too. So if you look at the Lapsus group in the last year, has claimed doing source code theft to some large organizations there, with Microsoft with their Azure DevOps instance, T-Mobile via their Bitbucket instance, and then Samsung and Globant with their GitHub Enterprise instance. And obviously in the last 2 years, software supply chain attacks have really become more popular. If you look at the SolarWinds breach, for example, that really enabled the compromise of multiple organizations in both the private and the public sector. I have 2 main goals with this research. So the first one was to bring more attention to securing these systems, and Black Hat is the perfect platform to do that. Secondly, there's not much research out there right now on attacking and defending these source code management systems, so it's my goal that this is going to inspire future research on defending these critical systems. Whether you're on offense or defense, you're going to get something out of this talk. You're going to learn some different attack scenarios against source code management systems. You're going to learn how to defend these systems. And lastly, from an offensive perspective, you're going to learn how to abuse these systems from both a privileged and a non-privileged context. And just before I get started, my perspective on this, I'm currently a red team operator. I've been doing it for a long time. Prior to that, I was a blue teamer. So that's the perspective that I bring with this research. I'm not a DevOps engineer, I'm not a software developer, and I'm not a system administrator. So now we're going to get into background on some source code management systems. So first off, what is a source code management system? To put it very simply, it manages source code repositories. It allows multiple developers to work on code at the same time, track issues, and it integrates with other systems within the DevOps pipeline, right? So other CI/CD systems. And if you look at kind of 3 popular systems that I included for this research, now these are 3 most popular that we see on our engagements, so that's kind of why I chose these for research. So GitHub Enterprise, GitLab Enterprise, and then Bitbucket Server. We see Bitbucket Server more than Bitbucket Cloud on engagements, so that's where I focus on the Bitbucket side. All of these, though, they support different hosting options, whether you host them on-premise or in the cloud, and they also support integrations into the DevOps pipeline. And when you talk about the DevOps pipeline, these systems lie within the build phase. So you kind of have your source codes developed, and then it's built, tested, deployed, and then ran in production. And as you can see here, all other phases in the DevOps pipeline rely on the integrity of the source code that is developed and maintained within these systems. And when you talk about source code integrity, let's talk about software supply chain attacks. So for a software supply chain attack, an attacker is simply injecting themselves into the development process at some point to deploy malicious code. There's 2 angles to this. You can either go after the build integrity, like the SolarWinds attackers did, or you can go after the source integrity. So my research specifically focuses on scenarios B and C in that diagram around going after these source code management systems. And you're going to see a demo of doing a software supply chain attack in this presentation. You're also, another useful scenario from a source code management point is these can be initial access points to other systems in the DevOps pipeline. So because they have integration set up, if you're able to compromise one of these systems, you could, for example, pivot to a CI/CD platform, pivot to a distribution platform. And you're also going to see this in the demos as well. Okay. All right, so now we're going to cover attacking and defending GitHub Enterprise. So the term enterprise with GitHub Enterprise is going to refer to the entire GitHub Enterprise instance. An organization within GitHub Enterprise, so an enterprise can have one-to-many organizations underneath it. And you have different enterprise roles and also organization roles within GitHub Enterprise. You also have different roles for repositories. So whether you can you just read a repository, do you have write access, admin access, etc. And then you have access token scope. So in order to access the REST API, you can authenticate with an access token or an API token. And you have different scopes applied to this, and that basically tells you what you're authorized to do with that access token to the REST API. And you're going to see kind of the abuse of the REST API in this presentation. So going to be abusing that in all these systems today. So each of them have a REST API that is basically a programmatic interface that you can interact with them to do different functionality. So now we're going to go through the different attack scenarios against GitHub Enterprise. Now, this isn't an exhaustive list. These are just ones that I've researched and also that our team has used during engagements. For full details on all these scenarios, make sure you check out my white paper, which I'll have a link at the end of the presentation. It'll also be shared on the Black Hat site. So let's talk about reconnaissance. So in terms of reconnaissance on GitHub Enterprise, really focusing on 3 primary aspects. So focusing on repositories, files, and code, because those are going to be the most value to an attacker from a reconnaissance standpoint. Now you can do this reconnaissance either via the web interface, the REST API, or you can also do that with my SCM Kit tool that I'll be showing later. In terms of logging for this reconnaissance, this activity is going to be logged in the HA proxy log. And I've got a search criteria there with a screenshot of me filtering for some of my reconnaissance activity. So you can see me there kind of searching for things like password or a Jenkins file. Another attack you can do in GitHub Enterprise is a repository takeover. So the site admin role in GitHub Enterprise is like the admin role within GitHub Enterprise. If you are a site admin, you can unlock any repository for modify access, and that includes private repositories. So you can see in the screenshot on the left, there's a private repository, and then on the screenshot on the right, I'm using my site admin access to unlock that repository where I have full access to all of its settings and any code in that repo. In terms of logging for this attack, this is going to be logged in the audit log on the GitHub Enterprise server. And the search criteria there for finding this activity is action repo.staff_unlock. Now, all of the search criteria and logs you're going to see through here, I have them all included in the blog post and the white paper, so you can take a look at those afterwards. Another attack you can do in GitHub Enterprise as a site admin is you can do user impersonation. So you have 2 options for this. You can either do an impersonate user login, and you can do that via the web interface, as you can see in that screenshot. Or a stealthier option is you can use an impersonation token. Now, you can create an impersonation token either via the web interface or the REST API. And when you create an impersonation token for a user, that user cannot see that impersonation token. Only other site admins can see that that user is being impersonated. This activity is going to also be logged in the audit log in the GitHub Enterprise server, and I've got a few different search criteria there listed as far as how you can detect this activity. Again, all the search criteria and the logs will be included. They're included in the blog post and the white paper. Another attack you can do is you can promote a user to site admin. So if you're a site admin, you can promote any other user to site admin or demote any user from site admin. Where could this be useful? Let's say you've compromised a site admin account, and you're worried, you're worried about them, basically you're worried about the blue team being your tail, right? And so you kind of want to switch to another user, but keep that site admin access. So you can promote another user to site admin, switch to that other user. And this activity is also going to be logged in the audit log. I've got a couple different search criteria listed there. And what's nice about the audit log is that it'll tell you whether something was done via the API or not. So it'll tell you whether something was abused via the API. So you can see in that screenshot there, it says this was promoted via the API by the A Dumbledore user. 3 options for persistence in GitHub Enterprise. So it's, obviously from an attacker perspective, you want to maintain persistent access to, those systems. So you can do that with personal access tokens, and you can create those as a normal user via the web interface. GitHub Enterprise doesn't give you the ability to use the REST API to create personal access tokens. You can also use impersonation tokens, like I mentioned previously. And then the last option is you can also use SSH keys for persistence. And you can do this as a normal user, either via the web interface, REST API, or you could use SCM Kit for that. The persistence activity is also going to be logged within the GitHub Enterprise audit log. As you can see kind of the screenshot there, me filtering for some of my activity. The last thing I want to mention for GitHub Enterprise is the management console. So there's a couple main consoles in GitHub Enterprise. So you have the management console, and then you have the site admin console. The management console is where you can configure the entire enterprise instance, and you access this via a single shared password. The site admin console is specifically for managing different facets of an organization, so think like role-based access for users and such. But some different things you can do in the management console is you can, for example, add your public SSH key to the GitHub Enterprise instance so that you can SSH to the server itself. Once on the server, there's a few different interesting things that you can do. The default SSH port is 122, and you'll SSH with the admin user account. One thing you can do is list the GitHub Enterprise configuration via the ghe-config command. This could contain Active Directory credentials depending on what the server is integrated with. Another file of interest on the server is the secrets configuration file. The secrets configuration file could contain API keys or SSH keys depending on what GitHub Enterprise is integrated with in that environment. In terms of logging, so for example, adding stuff, like adding public SSH keys in the management console, that's going to be logged in the management log. So you can see I have a screenshot there where I'm filtering for some of my activity, adding the SSH keys in that management console. Now we're going to get into attacking GitLab Enterprise. So in GitLab Enterprise, you're going to hear the term project. And you can use project or repository interchangeably. They mean the same thing. A project can host code, track issues, and contain CI/CD pipelines. And there's five permissions for a project or repository you can see there. From an attacker perspective, you're going to want to compromise a user that has developer or higher permissions. And just like with GitHub Enterprise, if you want to use an access token or an API key, there's different scopes that are applied to that authorize you for what you're allowed to do within the REST API. And just like GitHub Enterprise, there's a bunch of different things that you can do with the REST API, and you're going to see that in the demos. These are the attack scenarios that I'll be covering. Again, not an exhaustive list, just ones that I've researched, and full details on these attacks are in the white paper. Additionally, a number of these you can perform with the SCM Kit tool. So just like GitHub Enterprise, reconnaissance is important in GitLab Enterprise, focusing on repositories, files, and code. You can do this with the web interface, REST API, or SCM Kit. Now, in terms of logging, something that I thought was interesting. So this activity is logged on the production log and API log. But if you see the screenshot in the top right, the activity as far as what I was performing reconnaissance for was actually being filtered. So an alternative approach, I ended up using the access log. And the screenshot below, you can see when I use the access log filtering for reconnaissance activity, I could actually see that activity. Just like with GitHub Enterprise, you can also impersonate other users. So if you are an admin role within GitLab Enterprise, you can either do an impersonate user login via the web interface, as you can see in that screenshot, or the stealthier option, again, is creating an impersonation token. And you can do that via the web interface or the REST API. And again, only other admin users can see that an impersonation token was created for that user. That user has no clue that they are being impersonated. And this is going to be logged in both the production log and the API log on the GitLab Enterprise server. I've got some search criteria there. Again, all the search criteria and all the important logs are all included in the blog post and also the white paper. So I've just got a screenshot there for me filtering for some impersonation token activity. Another thing you can do, just like the other system, you can promote a user to admin. So if you're an admin in GitLab Enterprise, you can promote any user to admin or demote any user from admin. You can do this via the web interface, REST API, or SCM Kit. And this activity is also going to be logged in the production log and API log. So you can see a screenshot there, for example, of me filtering for that user promotion activity. Same three persistence options with GitLab Enterprise with a couple caveats. So you can create personal access tokens as a normal user in the web interface, or GitLab Enterprise gives you the ability to do this via the REST API as well, but you have to be an administrative user. You also have impersonation tokens, but that requires administrative permissions. And then the last option is SSH keys, which you can create those as a normal user, either via the web interface, REST API, or SCM Kit. Again, the production log and API log is where this activity is going to be logged. So the screenshot in the top shows me filtering for some personal access token activity, and the screenshot in the bottom shows me filtering for some SSH key activity. So another attack here is around you can modify a continuous integration or continuous delivery pipeline within GitLab Enterprise. So in GitLab Enterprise, there's a concept of these GitLab runners. GitLab runners will execute instructions from a GitLab CI configuration file. And that configuration file is going to be named .gitlab-ci.yml. and it's going to be in the root of the repository. So you're going to need developer, maintainer, or owner role for that project to modify that file. Once you do, though, that's going to trigger the pipeline to run for that project. In terms of reconnaissance, to find repositories that have GitLab runners available to your compromised user, there are some reconnaissance modules with an SCM kit that you can do that. So in terms of updating this configuration file via the web interface, it's going to be logged in the production log, but obviously you can just update this file via the Git command line tool. So really, any updates to the GitLab CI configuration file should be heavily scrutinized and require an approver before being pushed. So the last mention here for GitLab Enterprise is around SSH access. So a few different interesting things from an attacker perspective. A GitLab configuration file on the server, so that can contain credentials like Active Directory credentials, depending on what the system's integrated with. There's also a GitLab secrets file, and that could contain API keys as well, again, depending on what integrations are in place. And lastly, there's a PostgreSQL database on GitLab Enterprise. There's some interesting things in there. So you can see in that screenshot, I'm filtering like a users table for usernames, encrypted passwords, and one-time password backup code. So those are 3 interesting things from an attacker perspective if you have access, SSH access, to the GitLab Enterprise server. So the last system I'm going to cover attacking is Bitbucket, and then we're going to get into some demos and SCM Kit. So in Bitbucket, there's also the concept of project, and this is specifically Bitbucket server is what I focused on. And a project can contain one-to-many repositories. It's kind of like a container for one-to-many repositories. There's 4 main permission levels in Bitbucket server. You have global permissions. That's going to tell you what type of user you are. And then you also have permissions in projects and repos, so whether you are an admin to them, write access, read access, etc. And then lastly, just like the other 2 systems, there's different scopes that get applied to access tokens. They're called HTTP access tokens in Bitbucket server. And something that's different, though, with Bitbucket server is those access tokens are only scoped to be able to interact with repositories or projects. Having said that, though, there's a number of other different things you can do with the REST API in Bitbucket server. You would just have to authenticate with like a stolen cookie or a username password. And these are the attacks I'll go through for Bitbucket server. Again, not an exhaustive list. Full details on these attacks are in the white paper. And you can perform a number of these with SCM Kit. So just like the others, you can do reconnaissance via the web interface, REST API, or SCM Kit. However, one thing that I found was interesting when I was testing, doing this research, is that this activity is logged in the Bitbucket log. However, I'd had to increase the logging level in order for my reconnaissance activity to show up. So once I did increase the logging level, you can see there that my queries for searching for like API keys, whatever I was performing reconnaissance for, was actually showing up. Just like the other 2 systems, if you're an admin, you can promote any user to admin or demote any user from admin. And you can do this via the web interface, REST API, or SCM Kit. This activity is going to be logged in both the access log and in the audit log. So you can see there I have a screenshot kind of showing my user promotion activity within the access log. So 2 options for persistence with Bitbucket server. You'll notice that impersonation tokens are missing. And that's because there is not a concept of impersonation tokens within Bitbucket server. You can either create personal access tokens or SSH keys as a normal user, and you can do this via the web interface, REST API, or SCM Kit. And that activity will also be logged in the access log and audit log. I've got a screenshot there for some of my SSH key addition activity. Just another reminder, all the logs for this activity and search criteria is all included in the blog post and the white paper, which I'll have links to at the end of the presentation. So the last attack for Bitbucket server is around modifying CI/CD pipelines. So similar to GitLab Enterprise, but a little bit different. So Bitbucket is an Atlassian product. Atlassian also has a product called Bamboo. And Bamboo can be used as a CI/CD pipeline. So if a Bitbucket repo is using Bamboo as a CI/CD pipeline, it's going to have a bamboo-specs directory within the root of the repository. And it's going to have a configuration file within that folder. So it's either going to have a YAML file, which is bamboo.yaml, as you can see in that screenshot, or it's going to be a Java spec file, and it'll be pom.xml. And you're going to need write or admin access to the repo to modify that configuration file. But once you do, that's going to trigger that pipeline to run automatically. So you can see in the screenshot there, I'm adding some lines to the Bamboo configuration file to trigger the pipeline. This activity is going to be logged in the Bamboo log on the Bamboo server. So you can see a screenshot there of some of my activity updating this file. So again, just like GitLab Enterprise, any commits to these CI/CD configuration files should be heavily scrutinized. So as you saw with these three systems, there's a bunch of different things you can do with the REST API. And so I wanted to create a tool that would help automate that, because I didn't want to have to keep looking up the API documentation and doing curl requests during engagement. So that's where SCM Kit came about. So SCM Kit is a source code management attack toolkit. I wrote it in C# so that it can be ran in memory with command and control frameworks like Cobalt Strike. I have the URL there to the tool. I just pushed it this week. I also did a full presentation on the tool at Black Hat Arsenal this week as well. It supports attacking GitHub Enterprise, GitLab Enterprise, and Bitbucket Server, and has multiple modules for doing things like reconnaissance, privilege escalation, and persistence. So here's an example screenshot of running SCM Kit in memory. You're going to see these in the demos, but this just shows me using a utility called inline execute assembly, which is developed by a member of X-Force Red as well, Sean Jones, to be able to run SCM Kit in memory. So here I'm doing the code search module, searching for API secrets. Here's an example of using SCM Kit to do privilege escalation on GitHub Enterprise by promoting a user to site admin. And here's an example of doing persistence in GitLab Enterprise via a personal access token. So now we're going to get into the demos. So first demo I have put together, I'm going to do a software supply chain attack on GitHub Enterprise. Second demo, I'm going to do lateral movement from GitLab Enterprise to Artifactory, which is a package repository system. And then the third demo, I'm going to show doing lateral movement from Bitbucket Server to Jenkins. Okay. So just to set the stage here, we have access to GitHub Enterprise right now as a compromised user, hpotter, and we are interested in gaining modify access to the WandOS repository. WandOS is a fictitious piece of software that runs on all wands within the wizarding world. So we want to be able to gain modify access to this repository so that we can perform a software supply chain attack. So the first thing we're going to do with SCM Kit as our compromised hpotter user, who's just a normal user, is we're going to do the search repo module within SCM Kit, searching for WandOS. So we're going to go ahead and run this command within Cobalt Strike. I'm going to go ahead and paste this in here. All right, so we're going to run this command, and what you're going to see is that our hpotter user cannot see the WandOS repository. All right, so it must be some sort of like private repository that we can't see. However, as part of this operation, we found an API key on a file share. Now, during our engagements, we commonly find API keys on user workstations, file shares, internal wikis, and stuff like that. So we found this API key, and we want to validate this API key and see what privileges it has. So to do that, we're going to use SCM Kit with the PRIS module authenticating with that API key. So we're going to go ahead and run this command here and see if this API key is valid that we found on a file share and what privileges it has. And what you're going to see here, this API key that we found, and this is a scenario that we do during engagements, our adversary simulation engagements. We have actually conducted this scenario. So this has site admin access. So we have the site admin API key, and we have a regular compromised user, hpotter. So what we're going to do is we're going to use SCM Kit with the add admin module and that API key, and we're going to promote our compromised hpotter user to site admin. So we're going to run this command here. And what you're going to see is hpotter will be added to the site admin role. So now if we go back to the GitHub Enterprise web interface and refresh, what you're going to see is there's going to be a rocket ship show up in the top right. And that is the site admin console within GitHub Enterprise. So now we have site admin access within GitHub Enterprise. We're going to take a look at the users and see if there's any interesting users. This DevOps user looks pretty interesting. We're interested to see if maybe this user has some private repositories. So we're going to drill into here. This user has 2 private repositories. So we're going to check those out. And what you're going to see is that user, DevOps user, actually owns the WandOS repository, which is private. And that's why we couldn't see that as our normal hpotter user. So there's 2 options here. You can either do a user impersonation attack to impersonate that user, DevOps user, or what we're going to do is we're going to do a repository takeover by unlocking this repository. So we're going to go ahead, unlock this. By default in GitHub Enterprise, this repository is going to be unlocked for 2 hours. So you have to provide a reason here, and this is all logged on the GitHub Enterprise server. So now this repository, the WandOS repository, is locked for hpotter. So now we should have full access to the repo and its code and all of its settings. So now we're going to go back, and you're going to see here that now we will have access to the repository. And just to kind of further prove this, we're going to show kind of just with the git command line tool, we can also clone the repository down as well with the hpotter user now. So kind of this attack path, we were a normal user. We found a site admin API key on a file share. We used that API key to promote our compromised user to site admin, where we performed a repository takeover on the WAND-OS repository, and now we can modify that software as part of a software supply chain attack. The second demo, I'm going to show doing a lateral movement from GitLab Enterprise to Artifactory, which is a package repository system. So as I mentioned, in GitLab Enterprise, there's these concepts of GitLab runners, and they will execute instructions in a GitLab CI configuration file. So we're going to perform reconnaissance with our compromised user and see if our user has access to any GitLab runners. So we're first going to do this list runner module with SCM Kit. So we're going to go ahead and authenticate here and see if our user has access to any GitLab runners and what repositories those runners are assigned to. And you're going to see we're going to get a few hits here. The secret spells directory is the one that we're going to end up focusing on. So we have access to some runners. Now let's go ahead and do some reconnaissance for that GitLab CI configuration file. And we're going to cross-reference runners that we have access to with GitLab CI configuration files, basically repos that have both. And so we're going to do the search file module, search for GitLab-CI with SCM Kit. And there's going to be a couple hits that come up, but again, we're going to focus on this secret spells directory here. So you can see here, the secret spells directory has this CI configuration file, and it also has a GitLab runner that we have access to. So we're going to go ahead and go to this repo and try to modify this configuration file. Now, I'm doing this via the web interface just for demo purposes, but obviously you could do this via the git command line tool. And in this environment specifically, what you're going to see is there's some integration between GitLab and Artifactory. So it's basically pushing a file to Artifactory, which is a package repository system. And you can see what it's doing is it's authenticating with a username and password for Artifactory to push this file. So what we want is we want to get these credentials. So we're going to modify this configuration file to print out the Artifactory username and password that it is being used. So we're going to go ahead and update this file. And again, once you update this CI configuration file, that's going to trigger the pipeline to run automatically. So we're going to go ahead and commit our changes. All right, so you're going to see that. It's going to validate that it's a good configuration file. And then what we're going to do is we're going to go look at the pipeline and take a look at our job and make sure that it ran. And what we should see in the job output for our newly modified job with that configuration file is the Artifactory credentials. Now, why could this be useful from an attacker perspective? If you have access to Artifactory, you could upload malicious packages, right, that are used in other projects or that are deployed. So we're going to go ahead. You can see our pipeline ran. Take a look at our job, and we're going to view the job output. And what you're going to see in the bottom there is it did print out the credentials that were being used, so the Artifactory username and the password. So we're going to go ahead and validate these credentials by logging into Artifactory. So we're going to log in here with the admin username. Also, if you haven't noticed, my lab, I'm a big Harry Potter nerd, so that's why I've got all this Hogwarts stuff set up, so I'm a huge Harry Potter nerd. So you can see here we have access to Artifactory, where again, now that we have access, we can upload malicious packages. We kind of completed that lateral movement from GitLab Enterprise to Artifactory. The last demo I'm going to show is doing lateral movement from Bitbucket server to Jenkins. So Jenkins is a build system, CI/CD system, and Jenkins can be used, obviously, to build applications. So if there's an integration set up between a source code management system and Jenkins, it will run what's called a Jenkins configuration file, right, in a source code management repository. And that name of that configuration file is going to be Jenkins file. So what we're doing with our compromised user is we're using SCM Kit, and we're searching for any Jenkins CI configurations files with the search file module searching for Jenkins file. So we're going to go ahead and run this search here. And you're going to see a couple instances pop up. We're going to focus on this Marauders map app directory. So we're going to go to this Marauders map app repo and try to modify this Jenkins CI configuration file. Now, our goal here with this file, so when Jenkins runs the CI/CD configuration file, it runs on the Jenkins server itself. So what we're interested in is we want to perform lateral movement to Jenkins. So what we're going to do in this configuration file, and again, I'm doing this in the web interface. You could do it via the git command line tool as well. What we're going to do is we're going to have it execute some commands to add our public SSH key to the authorized keys file for the Jenkins user account. That way, we can SSH to the Jenkins server as a Jenkins user account. Now, this can be prevented on the Jenkins side if you have like sandboxing in place for Groovy scripting. So I'm going to go ahead and update this Jenkins file. And typically, like in a real-world environment, like during engagements, you just kind of let Jenkins run on whatever schedule it's running on to pull the updated configuration file, especially if you haven't compromised the Jenkins server. For this case, in this demo, I'm just going to run this Jenkins job manually so that we can see the results. So we're going to go ahead and run this Jenkins job. And again, it's going to pull that updated Jenkins CI configuration file from that repository and run it. And it's going to run the actions that we just put in there. So it's going to run who am I, the host name, and then add our public SSH key from our private public SSH key pair to the authorized keys file. So you can see there that that ran. So now we should be able to SSH to the Jenkins server as the Jenkins user account. So we're going to go ahead and SSH here with our associated private SSH key with the public SSH key we added. And you can see there we've successfully pivoted from over to Jenkins from Bitbucket. So this kind of shows an example of being able to take advantage of those integrations with source code management systems to pivot to build systems. So defensive considerations. For the SCM Kit tool itself, I have a YAR rule file within the repository with static signatures that you can apply for attackers if they were to use this tool in its default state. I also have a static user agent string within the tool, so that I've listed there. Now the reason for this is again to detect activity with this tool. So I have a snort rule that's included in the SCM Kit repo for this. Additionally, in your web proxies, you can add rules for this user agent string. Lastly, any access tokens or SSH keys that are created with SCM Kit, the names are going to be prepended with SCM Kit dash. So you can put rules in your source code management systems to detect any access tokens or SSH keys that are created with this in the beginning of the name. I'm not going to get into these logs and the log filters in details just because, again, they're included within the blog post and in the white paper. But for GitHub Enterprise, make sure you get these 3 logs forwarded to your SIM. And then I've got some rules that you can apply to detect the activity that I showed today within GitHub Enterprise. For GitLab Enterprise, make sure you get your application log, production log, API log, and web log forward to your SIM. And then make sure that you get these rules applied for the activity that I showed, all the way, reconnaissance, user impersonation, all those different attacks that I showed. Lastly, with Bitbucket server, make sure you get the access log, audit log, and Bitbucket log forward to your SIM. And then on the Bamboo server, make sure you have your Bamboo log forward to your SIM as well. Again, all these rules for all of these and all the logs you need to forward to your SIM, they're all included in the blog post and the white paper. In terms of configuration guidance across the board for source code management systems, in terms of personal access tokens and SSH keys, make sure that you set an automatic expiration date and don't allow users to create these with no expiration date. Think of these like passwords. Like we have expiration dates for passwords, so we should do the same thing for access tokens and SSH keys. In terms of access and authorization, limit the number of administrator accounts within these systems. At maximum or at minimum, there needs to be 2. You need to have a primary admin and a backup, but there shouldn't be more unless absolutely necessary. The more admin users, the more attack surface for an attacker. Make sure you enable multi-factor authentication. And lastly, disable user impersonation. As you saw, I took advantage of that feature within GitHub Enterprise and GitLab Enterprise. In terms of repository access and code commits, operate on a policy of least privilege. So don't just give everybody access to all repositories. Additionally, make sure that you delete code branches in a sufficient time. So I've seen time and time again where a developer will create some sort of like testing code branch. They'll commit credentials to it and kind of leave it left over for our red team to find. Additionally, whenever users are making code commits, require at least one approver for that commit so they can actually review to make sure there was nothing malicious in that commit, and require signed commits either via GPG keys or certificates. In terms of logging, so you saw I showed a bunch of different logs that you can use and some different detection rules. So make sure that you get those logs that I have forwarded to your SIM. And additionally, as you saw with systems like Bitbucket server, I had to increase the logging level to detect that reconnaissance activity. So increase the logging level when needed as well. So in conclusion, These systems, they contain some of the most sensitive information in organizations, and they're really a critical piece to organizations, and a key component in the DevOps life cycle where attackers are really focusing on these more and more. Because again, software runs on practically everything today, between our cars, traffic control systems, right, medical devices, right? So these systems are very important. Depending on the organization, right, compromise of a source code management system in one organization could lead to compromise within another organization. And then lastly, these systems, they really do need more visibility, and they need more research from the community. So kind of a call to action to you all is to, I really hope to see future research and somebody take this research to the next level to further defend these systems. Before I wrap up here, I just have some acknowledgments. Without these people, they supported me through this entire research project and gave me tons of really great feedback. Without them, I would not be standing here today. So I want to thank Chris Thompson, Daniel Crowley, Dimitri, Patrick Fussell, and Ruben Boonin. So as I mentioned, the blog post and the white paper URL, I'll leave this up here. That's got, the white paper is going to have full details on what I talked about today. If you have any questions, feel free to hit me up on Twitter or Discord, or come talk to me after on the hallway. I'm happy to answer anybody's questions. With that, that's it, and I thank you very much.